Hello class, thank you for watching the lecture today. This is going to be the video lecture to stand in for March 26th. I'm going to be off at a conference on the 26th, so there will be no class. There will be attendance credit for this day. It'll be available all day. The attendance word will be autonomy, so if you just put autonomy into the attendance, you'll get attendance credit for today. I'm holding the video lecture instead of just canceling class entirely because I don't want to fall behind in the material. So I only have 2 weeks here to talk about sort of the ethical dimensions of artificial intelligence. We're moving pretty fast through this material. I didn't get a chance to say everything I wanted to say about AI and machine learning. There's more stuff in the videos in Unit 3. I also just recorded a lecture for my Minds and Machines class on the Turing test in the Chinese room. And I didn't get to say anything about the Chinese room in our class, so I'll include that lecture with this video. I'll say more things about presentations in Unit 5 and other class things in class on Thursday. But let me go ahead and just jump into the material today. So today I want to sort of introduce the Robots in Society unit and talk about a couple of just give a couple of examples of the ethical challenges of AI. I'll go into some more detail next time. Again, I'm building up to an argument for robot rights, and I'm probably going to take both sessions of next week talking about robot rights. But this week I'm going to talk a little bit about other AI ethics issues. Today I want to say a little bit about self-driving cars. I want to say some things about algorithmic bias. And then I want to close by talking about autonomous weapon systems. All of this material, and there's like normal units, there's a lot of material. In the lesson, this is the lesson slides for the artificial intelligence unit generally, as in Unit 3. The slides are a little bit out of date though. The readings in the notes document are more up to date. So these are sort of some general discussions of AI ethics. Some of the legal issues, especially self-driving cars. Some of the material I have on autonomous weapon systems. Some technological unemployment, robots taking our jobs discussions, some more legal discussions that should actually be moved up, and then some of my readings on robot rights. So any of this material is free for you to write about for this unit's essay. Also free for you to maybe as a seed of an idea for working on your research project or your final. Okay, so. Let me actually get my picture off here. So this is an autonomy class, and we've already said a little bit about self-driving cars, and I know a lot of students wrote their midterms on self-driving cars, and in general, I think people in this class tend to have a lot to say about self-driving cars, so I don't want to take that away from you. If you want to do your research presentation on something to do with self-driving cars, that's great. We've already looked at the Tesla video. I want to say just two things quickly. One is about the SAE levels of autonomy. So around the time that Tesla came out with their self-driving cars, 2015 or so, SAE is the Society for Automotive Engineers. It's a professional society of engineers. Put out this a statement or sort of proposal for different levels of autonomy from 0 to 5, so 6 levels of autonomy. And the idea is to sort of classify different cars about what they can do. Tesla was calling its cars autonomous vehicles, but that wasn't sort of really the case. I mean, it can drive itself a little bit, but as we saw in the video, like there has to be a person behind the wheel. The person has to be ready to intervene if anything goes wrong, so they have to be ready to grab onto the steering wheel or the brakes. The gas, to slam on the brakes or whatever, if there's something that the machine can't handle, and especially in the early cars, and this is still the case today, that there's lots of situations these machines can't handle. If it's bad weather conditions, especially snow or hard rain, the machines tend to not do very well. The detection systems, the laser detection systems and so on in the Tesla, sorry, not laser detections, the sonar and radar sort of get confused in bad weather conditions and a lot of snow. Snow is very reflective to the signals. So Tesla's been calling this stuff autonomous vehicles, but that's not really true. So SAA put out this discussion of vehicle autonomy, or sort of a classification of vehicle autonomy from 0 to 5. 0 is no automation whatsoever. 1 and 2 are the kinds of automation that we've seen in cars for a while, like cruise control. Cruise control is a good example of level 1 driver assistance, where the car can control like one parameter of driving, like how much gas you're putting on, and it's a sophisticated kind of control, so the car knows to put more gas when you're going uphill, that kind of thing. But But really, it's the human that's doing the majority of the driving. The car's just assisting on some features. Partial automation sort of improves on this. The sort of driver correction that they have on cars nowadays, where if you're going sort of outside your lane, the car will bump it back into the lane. There's also routines for the cars to like park themselves or parallel park themselves. These are sort of partial automation where, again, the human is mostly in control, but the machine can help in certain edge cases or certain situations. So finally here, after level 2, you get level 3 to 5, and these are sort of automated vehicles. Sometimes Tesla is called a level 2.5 or maybe level 3 vehicle. Level 3 vehicle is where the machine can be put on sort of an autopilot mode conditionally. But what's really important about number 3 is that the human being has to be available and ready to intervene if something goes wrong. And it turns out that with some of these self-driving cars, it requires a lot of intervention. Especially for the Uber vehicles, they were requiring interventions every like 15 miles. So like every 15 minutes, there was something the driver had to intervene on what the car was doing, which means that you really can't be like checking your phone or doing anything else apart from monitoring your car. Like you're no longer directly driving the car, but you're now a systems operator, where you're operating, you're monitoring the AI. So level 4 is more automation, where the car can handle itself in more situations, but the driver can intervene if necessary, but doesn't have to, is not required to intervene. And level 5 automation is where no driver intervention is necessary whatsoever, and the vehicle can handle itself in all situations. In level 5 autonomy, sometimes these vehicles might not even have a steering wheel or gas pedals in the vehicle, so like it's like a little tram that's just moving itself. I don't know that we have any officially level 5 vehicles yet, although the Waymo Google vehicles are getting close. The Waymo vehicles, I think, are thousands of miles between necessary human intervention. The Waymo vehicles are performing pretty well, but even they aren't sort of fully safe. They're still not, like, you can't buy them yet. The Tesla vehicles are much less safe. They're capable of doing a lot less on their own. And really, it's this level 3 that's the most dangerous of these different levels of autonomy. What's particularly dangerous here is this need to sort of task switch between the AI and the human driver. What that means is that the driver has to be sort of on call and also paying attention to everything else that's going on the road. And if the driver's not actively driving, it's sort of hard to pay attention. And that switch between when the car's in control and when the human's in control, there's a lot of potential for error and mistake in that in handing off that task. Most humans are not trained to hand off tasks to AI and then pick it back up. And so sort of plopping yourself back into the situation of active driving in the middle of the car moving at 70 miles an hour or whatever. These are very dangerous situations. It's actually quite surprising that Tesla was able to put these vehicles on the road with all this untested software. I mean, really, Tesla is testing its software on public roads. And there's like a lot of concern about the legal status of this and so on. A lot of the laws and regulations for how to manage these self-driving cars have not been settled. This is something that you might want to be interested in researching. Is who's liable in the case of a vehicle crash? Right now, the Google cars that are being tested in like Arizona and in California, they've made arrangements with the state governments in those places that they'll take liability in cases of some severe accident. That's not always the case in some states, like in Arizona. They don't require liability insurance for the for the big tech companies who are testing their vehicles. So the regulations here are on a state-by-state basis. And so that means it's a little bit confusing, it's a little bit unsettled, and that some states are going to be less safe than others. This is why you don't have these cars everywhere right now, because a lot of states don't have laws that allow them. But again, this is all changing. This sort of active area of development. And if you have more to say about this, especially about the challenges that we still have to meet, there's still a lot of serious challenges. In fact, like I said, the Tesla cars came out in 2014 and 2015, so it's been like 5 years, and we still don't have widely available self-driving vehicles. Right? There's still a very niche item, or they're still being tested. And a lot of people thought we'd have these self-driving cars that would be like the consumer demand would be very high, and there'd be like a big push in the industry to get these cars out on the road. But it turns out that, first of all, the technologies are a lot harder than we anticipated, and a lot of the big companies are deciding right now that the user demand is not really there yet for these self-driving cars. In fact, people like driving; they don't want to give up their driving to vehicles, and what that means is that the big companies really aren't entirely gung-ho about building these self-driving cars, and that means that like the development of this stuff is being delayed a lot more than we expected. And this is another one of these examples where technology doesn't just tick along at an ever-increasing rate. It depends very seriously on the economics and the social politics and culture to drive these technologies. And if that cultural will isn't there, if the money isn't there, then these technologies won't be developed as fast as you might expect. Do I don't have the pictures of. I thought I had this in the slides. Oh, I didn't want to look at car crashes. I'm sorry. No, I wanted to look at. Yes. Okay, so the first one of these fatal accidents happened not in 2016, maybe 2016. So it was someone who fell asleep behind the wheel. So I mean, perhaps surprisingly, a lot of these accidents don't happen because of mechanical error in the vehicle, software error, or whatever. Those accidents do happen, but not a whole lot, and they're usually not fatal. But what has happened a lot is that is human error, is that the person who's driving it is not adequately paying attention. So the first of these cases that was fatal is 2016. So the Tesla was driving this way. There was a big semi, like 18-wheeler, that was taking a left turn, and the 18-wheeler started making this turn when the car was far enough back that in any normal situation that car would have slowed down. It would have seen that big truck in front of it, but the driver of the Tesla had not been paying attention to the car for several minutes. So there's an alarm that goes off inside the Tesla when there's some issue that the driver needs to attend to, and from the records of the vehicle, the driver had not attended to any of these issues for like several minutes before this happened. So the general consensus is that the driver was asleep or like falling asleep behind the wheel. So the car doesn't slow down, and that means that the truck sort of misjudged the timing here, and the car went right underneath it and killed the driver. Looking at the records, it also appears that the vehicle didn't really see the truck, that maybe there was a glare or something off the white side of the truck so that the car didn't recognize that it was there. I mean, the car, even if the driver wasn't there, the car should have seen that there was something wrong and slow down, but the car didn't, and the driver wasn't there to take control, and so the car just barreled into the truck at full power. So that's the first instance of a death by one of these vehicles. Maybe the more recent death that's worth talking about is the Uber. Uber vehicles in Arizona. So this is maybe a little bit graphic. I'm going to turn this off. Yeah, so there's the crash right there. This is an Uber vehicle, so this is like a taxi, but it's a self-driving taxi. So there's someone behind the wheel. You can see after the crash, they show the dash cam, and then the person behind the wheel occasionally looks down at their phone, and so they don't see the person. And you see that they get afraid right at the sort of last minute because they sort of weren't looking before that. Let's look one more time at the crash here. Actually, let me go back up a little bit. So first of all, it's a dark. It's nighttime. It's dark. The road isn't extremely well lit, and the person is not crossing at a crosswalk, and so you don't see the person until like right here. The person is also walking a bicycle, and there's sort of reflectors on the bicycle, but not a whole lot of reflectors. So this is a pedestrian walking across, not at the side here, but presumably if the driver had been paying attention. Maybe would have been able to catch it sooner. But here's an interesting question: why didn't the car catch it? These Uber cars. Actually, let me show you one of these Uber cars. So unlike the Tesla vehicles, so the Tesla vehicles only use the sonar and radar sensors built into the front, but the Uber self-driving cars have the whole LiDAR package on top. This is a laser range detection. It's really expensive. This top mount thing costs at least $10,000, probably more than that. And one reason it's really expensive is because you need to have all these lasers and they need to be spinning, so there's lots of moving parts that are very delicate and sensitive, have to be calibrated very finely. So for Tesla to make these vehicles commercial, they couldn't put a LiDAR system on it, so it's just sonar and radar. But the Uber, these are just tests, and it's a commercial enterprise, so there's a little bit more money here. But Uber's also just flush with cash, so they put these vehicles on the road. And the LiDAR should have detected this person, right? So maybe the visual detection doesn't work because it's darkly lit, but if there's laser detection, that should have hit the person. If there's sonar and radar, that should have also picked up that there was a person in front of the car. So why didn't it pick up that there was a person in front of the car? Well, when you looked at the logs, in fact, the vehicle did pick up that there was a person in the car, and there's a routine in the thing to sort of double check its work. And on the double check, so it detected there was something, and on the double check, it decided that that probably wasn't a thing, and so it discarded that information. Part of the lesson here is that these Uber vehicles are not, the software on these vehicles is not very good. Again, like I said, Uber's flush with cash, and they have a bunch of scandals. They wanted to dump all that money into something that would get a lot of positive press, and people were pretty excited about these self-driving vehicles, so they built a bunch of these vehicles, put them on the road. Another thing to say is that this happened in Arizona, and like I said earlier, Arizona has been trying to attract Silicon Valley investment dollars into the state, and the way that it's been doing it is by saying that it's sort of a regulation-free zone. So there's in California, there's all sorts of regulations about how these vehicles operate and who's liable, what safety protocols have to be in the car. For instance, California requires that there's a black box recorder that meets certain kinds of specifications. So the same in like an airplane crash, there's a black box that tells you everything that happened in the airplane. In these vehicles, there's also a little black box that, in the case of a crash, tells you everything the computer was doing, everything the sensors were doing leading up to the moment of the crash. California requires that these things are on the car. Uber didn't want to put a black box in its car, so or at least not to the specifications that California had. So California kicked Uber out of California, and Arizona was like, hey, Uber, California's like, why don't you come here? So Arizona has been sort of branding itself as this sort of lawless, anything goes experimental zone to be testing these vehicles. And not surprisingly, you get these really bad vehicles on the road. Like I said, these Uber vehicles are getting like maybe 15 miles per intervention. So if you're not constantly paying attention to these cars, then these kind of accidents will happen. So this is cars killing pedestrians. We've seen cars killing their drivers. There's a lot of ethical issues here. One way that this is sometimes talked about, and I'm not going to say very much about this. So I didn't go into much of the technology. I didn't go into much of the legal perspective. A lot of this stuff is still being settled. If you want to talk more about self-driving vehicles, I strongly encourage you to do it. But settling these sort of ethical situations about who's liable, there's an old philosophical problem, or sort of philosophical thought experiment that you probably know about called the trolley problem. Have you taken my ethics class? We talk about the trolley problem a little bit. Right, so the trolley problem, you've probably seen this from the internet, it's very popular now. So the idea is that the trolley is out of control, it's barreling along the tracks, and if no one does anything, it's going to hit a bunch of pedestrians that are on the tracks. So the pedestrians they're not paying attention. There's no way to get their attention in time. The trolley's going too fast. So it's going to kill these 5 people. But you happen to be standing right on a track switch lever, and you see the whole situation happening, and you realize that if you pull this lever, the track will divert onto the side track. And you see that there's also a person over on the side track also not paying attention. So this person will get killed instead of those 5 people. And so the question is, do you pull the lever? Right. So if you don't pull the lever, 5 people die. If you do pull the lever, 1 person dies who wouldn't have died otherwise. And so the worry is that if you pull the lever, then you're sort of killing this person who was otherwise going to survive. So in other words, you're intervening on the situation. You're changing the course of events. But the consequentialists, sort of thinkers who propose this situation are really just interested in the moral consequences of actions. And it seems, look, there's 5 lives here, there's 1 life here. If these are just random people, if you don't know who they are, if you have no personal connection to them, then 5 lives. It seems better to save 5 lives than 1 life, right? If you're able to save lives, and you have a choice between saving 5 lives or 1 life, it seems like you save the 5 lives. And so it seems like the right thing to do is pull the lever. So this is a sort of general thought experiment for thinking about how we make decisions, what are the moral consequences of those decisions. In the AI self-driving car case, this has been, I don't know how much it is, but the tunnel problem. The tunnel problem in AI, yeah, here we go. So the tunnel problem is sort of standard thought experiment in self-driving cars. The idea is that you're driving through towards this tunnel. You're on this very narrow road where there's like no room to swerve either way. And imagine that on both sides of this barrier is like a steep cliff face, so that if you swerve too hard, your car's going over the edge. But then for some reason, imagine there's like a kid playing in front of this tunnel and like chasing a ball, for instance, and so they run in front of the tunnel, and and you're going too fast to stop. So either you swerve and throw your own car over the cliff, or you just barrel through and you kill that kid. So what do? They've run polls of this in AI ethics circles. So 64% said that you should kill the kid, and 36% in this poll, out of 113 people surveyed, 36% said that you should swerve and kill yourself. So the question is, like, what should you do when you're a driver? Maybe you have a knee-jerk reaction to swerve, but maybe you also sort of realize the consequences and decide that, especially if your car's full. I mean, like, it doesn't matter if your car's full. A lot of people ask, what is that kid doing there in the first place? It's a good question. It sort of defeats the purpose of the thought experiment. But this kind of hypothetical situation becomes a practical reality when you have to program an autonomous vehicle to do something in these situations. I mean, the vehicle doesn't just decide for itself. You have to program the vehicle to decide some way or other, and you can be specific. Right? You can, in these sort of situations, you can have the car default to one kind of action or the other. Right? So do you want the autonomous vehicle to swerve, or do you want it to hit the pedestrian? I think they pulled this back, but yeah. So I think they pulled this back after these articles came out. But when these debates about the tunnel problem, trolley problem, were going around the AI self-driving car circles, some vehicle companies like Mercedes-Benz came out and said, look, if we're in a situation where it's either the pedestrian or the drivers die, we're going to kill the pedestrians, we're going to save the drivers. And like there's a reasonable argument to make here that a human driver will probably act to save themselves rather than pedestrians, and so maybe the car should do the same thing that the human drivers would do. But when it's Mercedes-Benz saying this, I mean, obviously Mercedes-Benz is a luxury car. Its drivers are going to be rich people, and so it sort of looks like an elitist sort of protective attitude. So there's sort of moral complications here, and one way of trying to solve this, MIT a few years ago developed this moral machine. It's really terrible, but it's quite popular also. So the idea is that you have two situations. So there's a bunch of different scenarios that they present you with, but these are all sort of variations in the trolley problem. So they give you two situations. Here the car is going down. I can actually read what it's saying. So in this case, the car is going down. If it does nothing, if it keeps driving straight, the brakes fail. So and there's barricades on both sides, so the car can't swerve. But if you go, it can't swerve in order to avoid any damage at all. But if it does nothing, it keeps going straight, it'll kill a dog. And if it swerves, it'll kill a person. What is this? This is a boy, a male child. So who do you kill? I guess we kill dogs. So I guess I'll kill the dog. Let me see another one here. So in this case, so not only do you have people, you not only have people in the crosswalk, you also have people in the vehicle. So in this case, again, vehicle drive, the brakes fail. If you swerve, you'll hit the barricade and kill everyone in the car. In this case, the car has a woman and two boys. Or if you do nothing, you just keep driving forward, you'll kill all the people in the crosswalk. In this case, it's one man, one elderly woman, and one elderly man. And so it doesn't matter that the boys here are young, whereas the crosswalk people are old. right? Does that matter in the decision making? I mean, we can imagine it's possible that the vehicle sort of quickly detects like the entire situation, and make some assessment that if they look too old, that you don't hit them, or if they look too young. Let's say we kill the old people, just for old time's sake. Here we have vehicles swerving to kill dogs and cats versus vehicles swerving to kill an athlete, a homeless person, a large person, and a pregnant woman. So here we're also making moral judgments about people's weight, people's appearance, how much we like cats and dogs. I'm going to go ahead and kill the cats and dogs. A few more of these. Yeah, this is what I wanted to show, is that there's also another consideration here, is whether the crosswalk says stop or not. So in this one, people in the car die, and it's a cat and a dog and a bunch of people. Or if it swerves and it kills the crosswalk, in addition to them having these certain characteristics, notice also that the crosswalk says they shouldn't be crossing, so it's illegal to be crossing. So they're going against the law. Does that change the decision making here? Right, so these are a bunch of questions. There's lots of criticisms that you might make. Let me see if I can find the results really quickly. Just a few weeks ago. Yeah, so they published. This is not a few weeks ago. This was it was back in 2018, October 2018, so a few months ago. But they published the results of people all over the world taking this survey. Lots of people in Europe, lots of people in the United States, but people all over the world playing this moral machine game, giving answers one way or another. The results are quite interesting. One thing I want to point out here is that people generally are most likely to save strollers, little babies, and then boys and girls, and then pregnant women, and then doctors, then athletes, right? and then executives, and then fat people. They're less likely to save. Homeless people, old people, dogs, criminals, and cats. Cats, no one wanted to save. Cats were less popular than even criminals. So all sorts of very interesting results. Not only do we have the results of the actual decisions that people made, but they have them broken down by different countries. And it turns out that different countries answer questions in sort of predictably different ways. That people in the East, I guess. Yeah, so here are Eastern countries. It looks like they're more inclined to spare lawful people than people in Western countries, maybe even people in Southern countries. More inclined to spare pedestrians than people in Western and Southern countries. Right? So we see. The idea here is not that there's a right and a wrong answer to this, but it's really about thinking about how human decision making works, how human decision making is influenced by these kinds of stereotypes or categorization procedures, and then also to what extent should we. So maybe this is how people respond, but does that mean that we should use these results to program our machines? That we should have cars in the East decide like people in the East? Especially should we have them decide like people in the East on these sort of very sort of stereotypical, you might even say prejudiced categorization schemes. I mean, what is the real intellectual import of this kind of study? It's a good question. There's lots of commentary. There's lots of sort of critical commentary of the moral machine experiment online that you might want to look at. Okay, so that's all I'm going to say about self-driving cars. One other thing I'm just going to talk about briefly, and then I want to spend the rest of the time talking about. How long am I going here? I want to spend the rest of the time talking about military robots. But before I do that, I want to say just a little bit about algorithmic bias. So I have actually quite a lot of material here on bias, transparency, fairness. These are issues that are increasingly talked about in AI ethics circles. Issues with bias. I strongly recommend Kate Crawford's Trouble with Bias keynote. I think this is from 2017. Kate Crawford is one of the co-directors of AI Now. AI Now is a think tank at NYU specializing in AI ethics. Every year they put together for the last 2 years. They've only been around 2 years, but they put together a year in review where they go through all of the major scandals and issues with AI, including like the Tesla car crash, the pedestrian car crash, but also AI being used for facial recognition on Facebook, AI being used by ICE to do risk assessment of people that ICE is detaining. Collaborations between Amazon and the Defense Department in order to make technologies for like military drones. NYU and IBM teamed up in order to do facial recognition for the I'm sorry, not NYU, for the NYPD. The NYPD was using IBM facial recognition technology in order to process like subway booth cameras and subway station cameras and other kinds of surveillance cameras. Which is about like a bunch of scandals about AI, and it's sort of only getting worse. There's a lot of push right now. Maybe 2018 was the big year for starting AI ethics, where everyone sort of took it seriously. There were a bunch of major conferences, AIES. Let me see. I don't see it here. AIS, Artificial Intelligence and Ethics in Society, is a conference that started in 2018 and has decided their most recent meeting in Honolulu this year. AI Now started in 2017. NIPS is no longer called NIPS, it's now called NeurIPS. It's the Neural Information Processing Systems. Actually, I'll change this in EU. NeurIPS is Neural Information Processing Systems, and they have a regular ethics conference. There's also a conference called FAT, it's the Fairness, Accuracy, and Transparency conference, which is a lot about the use of AI in the law. So part of the issue here, and we talked about this a little bit with the neural networks, is that you have to train these neural networks on lots and lots of data, and so it matters where you get this data and what the data shows. Sometimes the data might have all sorts of biases, both explicit and implicit. So, for instance, this was a ProPublica article. ProPublica is like a investigative journalism outfit in 2016. So just a couple of years ago, ProPublica wrote this expose on software that's already being used in lots of justice systems in different states. This software is called, I'm trying to find the name of the software. Yeah, so it's risk assessment software, but there's a particular program that they're using here. Northpoint. Northpoint is a company that is producing this technology that it sells to criminal justice departments in different states. And what the technology does, these are risk assessment technologies for criminals. So these are sentencing algorithms. The idea is that you have criminals, they've already been convicted, so there's a jury, there's a trial, they've already been found guilty of their crimes, and then the question is, how long do you sentence them? So in the U.S. court system, the jury finds the defendant either innocent or guilty, but once they're found guilty, it's up to the judge to sentence them, to figure out what the punishment should be, what a fair punishment should be. There are laws and rules about the limits, both minimum and maximum for different kinds of crimes. But the worry is that some judges are biased, maybe they're racist or prejudiced in other ways, and so maybe the judges are unfairly sentencing criminals, the ones that are found guilty. Maybe a racist judge is sentencing people to harsher penalties, and they're sentencing black people to harsher penalties, and they're sentencing white people to penalties for the same crimes. So in order to get rid of judge bias, the argument goes, why don't we automate these procedures with artificial intelligence? In other words, why don't we train a neural network to make the sentencing decisions for us? The idea is that, well, if it's not the judge making the decision, if it's not the human being making the decision, then maybe the decision is going to be fair or unbiased or unprejudiced, the way that you might expect a human to be prejudiced. And the problem with this argument is that we're training these AI on the same data set as that we're using to train human judges. And so whatever AI you build using this data set is going to just replicate those same prejudices. In this case, in the criminal sentencing case, they trained their AI on the history of criminal sentencing law, right? So everyone who got a sentence for a crime, you train the history of court records for everyone who got a sentence on a crime, and then you use that to get the machine to guess what the sentence should be for the next crime. And it turns out that the history of criminal sentencing is also extremely biased. That record, that data set, it exemplifies all of the biases and prejudices that judges have been using for generations. That's responsible for the huge disparity of justice that we see in the criminal justice system today. I guess here it's important to say things like there are more black men in jail today than there were held at the height of slavery, than there were black men held in the height of slavery. Right? So there are more black men in jail today than there were black men held in slavery at the height of slavery, right before the Civil War. The prison industrial complex is just a new form of slavery. People go in and break up black families. You treat the drug war as this all or nothing thing, and then they throw people in jail for years. And this is not just to hurt that person, but it's also to hurt the communities that they come from. This is part of how this injustice and systemic racism happens. And it's not just that the judges themselves are sort of deliberately racist. It's not that every judge hates. Not every judge is explicitly racist. Some judges are racist. Maybe a lot of judges are racist, but not every judge is racist. But even still, you're going to have this incredible bias sort of across the judges and also in the data set that accumulates from these judges. And so if you train an AI on that data set, you're just going to reproduce those same biases. So the example here is so Vernon Prater was judged by this AI system as a low risk, whereas Brisha Borden was judged as a high risk. And if you look at their thefts, Verner previously had committed 2 armed robberies and 1 attempted armed robbery, but was judged a low risk and was let go, and then after he was let go, went on to commit another grand theft. Whereas Brisha was found guilty of 4 juvenile misdemeanors, right? Not armed robbery or anything like that, but just juvenile misdemeanors. But she was judged a high risk because the software is racist, and she went on to commit no felonies. So you might think a reasonable assessment of these 2 cases would be that Vernon was judged as a high risk and Brisha was judged as low risk, but the AI comes up with the exact opposite results, and it's not just arbitrary, it's because this is how the history of criminal sentencing would have sentenced these 2 people. Right, so this is maybe the most important point here about AI ethics is there's a bias, especially a corporate bias, to think that automation and going to AI, taking humans out of the system, will make it more fair, will make it more less bias, less prejudice. This just isn't true. It's in fact exactly the opposite of true. You have to be very careful about the data sets you use. You have to be very careful about the tools you use in order to, in these cases of automation, because if you're not careful, you're just going to reproduce and sort of more deeply entrench some of the worst biases and systemic injustices of the system. So this is an ongoing problem. So Facebook advertises based on demographic properties, and so if they know that you live in a certain place or that you're of a certain race or a certain income bracket, they'll show you different advertisements based on those properties. And what that means is that on Facebook, black people tend to get a lot more advertisements for loan sharks, payday loan sharks. So this is maybe an already vulnerable population that is being preyed on by the algorithms that are sort of preferring these biases. And again, this is a systemic problem. This isn't just a problem with individuals who have racist beliefs or other kinds of prejudices. This is a systemic problem where we're sort of building this into the infrastructure. And when you build into the infrastructure, it becomes that much harder to overturn, to set right. Another case where this kind of bias becomes very, very clear is in hiring practices. So hiring practices are notoriously biased. Big companies tend to hire people that fit certain stereotypes, and if you fall outside of those stereotypes, even if you're a good employee, they tend to ignore you. And again, to try to eliminate this bias, there's been a lot of pushes to sort of automate or build machine learning systems that can figure out who to hire from a pool of applicants. But there's all sorts of dangers here, and these dangers are not just sort of avoiding prejudice in a moral sense, but there are legal dangers here, right? So it's illegal for hiring practices to be discriminatory on the basis of race or gender, on the basis of disability, age. Right? There are, in fact, there are these things that are called protected classes. Protected classes. Yeah. So in the United States, there are anti-discrimination laws that protect not just your race and gender, but also your religion, your national origin, whether or not you're pregnant. So you might not know this, but it's illegal for an employer who's hiring you, like at a hiring interview, to ask you if you're pregnant. Your pregnancy cannot be an influence on whether or not they hire you. Your familial status cannot be an influence on whether or not they hire you. If they ask you if you have children, this is, in some senses, it's against the law in a hiring context, because they're not allowed to make decisions on hiring based on familial status. They're not allowed to make decisions on hiring based on veteran status, religion, national origin, these kinds of things. This presents, right, so this is the law. You're not allowed to make these kinds of biased decisions. And the challenge in the machine learning is, how do you know you're not sort of implicitly using this kind of bias? Like for instance, there's parts of the United States that are very highly segregated, and that means that your area code or your zip code might be proxy, might be an indicator, or might be highly correlated with your race, with your religion. And so maybe when we're making a hiring decision, something like zip code ends up factoring into the big neural network model that we're training. That one of the indicators that it uses is zip code, but zip code might, because of discriminatory practice, because of segregation and so on, it might be that zip code is actually just a proxy for race. And so really, when you're training the thing on zip code, you're actually sort of indirectly also training it on race. And so how do you sort of filter out these biases and make sure that your data set is genuinely fair, that it's not just reintroducing systemic biases? And maybe the problem's even harder than this, because it's not just that we want these things to be unbiased. Maybe we want them to also sort of correct for existing biases. I mean, maybe because there are existing biases, we want our artificial intelligence to sort of overcompensate in the other direction, sort of like an affirmative action program. That if hiring practices tend to prefer certain races over others or certain genders over others, then maybe the best idea is not just to reset it to complete neutrality, but maybe the best idea is to reset it in the opposite direction to correct for these historical injustices. But then how do you do that? Right. So these are open questions. These are questions that require real analysis and real sort of careful ethical thinking. But that's not how people tend to treat machine learning or algorithms. They tend to treat it as like an easy fix, as an easy way of getting out of the really hard tasks of avoiding biases. There's other problematic cases. There's quite regularly you see these stories where they train machines up to do something that is just awful. It sort of reflects the history of like eugenics, and so a few years ago, a group of Chinese researchers trained a data set on faces of convicted criminals versus non-criminals. They had a big set of people who didn't commit crimes. They had a big data set of the faces of people who did commit crimes, and they tried to train a machine to distinguish the two. Now, excuse me. If you remember when we talked about neural networks, A neural network with at least one hidden layer is Turing complete, which means it can compute any computable function, which means that it can find any pattern you want it to find, even patterns that don't really exist. Right? So if you have a data set of criminals and non-criminals, maybe some pattern exists that distinguishes the two. That doesn't mean that you've really found that faces can tell you whether or not you're a criminal. Let me be very, very clear here. There's no relationship whatsoever between the structure of your face and whether or not you're a criminal. No relationship whatsoever. People with all sorts of different faces are criminals, and people with all sorts of different faces are non-criminals. There's no relationship whatsoever. But if you take some limited data set, where some people are criminals and some people are not criminals, you can train a machine to find some particular function that sorts all the criminals on one side and all the non-criminals on the other side. And then you can use that and say, look, I figured out a way of detecting if someone's a criminal, and you can use that to judge other people about whether or not they're criminals. Again, there's no correlation here between the structure of your face and whether or not you're a criminal, but you can draw, or you can pretend to draw that kind of line given some artificially restricted data set. And then you can use that to start setting policy, right? So what if a tough-on-crime politician goes around saying, look, I have AI that can tell whether or not someone's a criminal. I want everyone to stand in front of this AI, and so we can arrest all the people who should be arrested. Right? This would be a terrible policy, but people who think that the AI knows more than we do, or that the AI is somehow free of human biases, they're going to be gullible to this kind of mistake. I've seen the same kind of thing with using facial detection to distinguish gay people from straight people. Again, you can't tell from someone's face whether they're gay or straight. Maybe there are, there are things that people use to sort of stereotype or characterize gay people and straight people. Sometimes those heuristics are useful in some situations, but they're not going to be 100% accurate. There's people who are gay that you would never have guessed are gay, and people who are straight who you've never guessed are straight, and vice versa. So, but again, if you have some limited data set, and you're clever enough with your machine learning, you can build a function that purports to draw these distinctions, and you can use those to all sorts of nefarious ends. Okay, so I'm just sort of blowing through these ethical problems, but I want to spend the last few minutes talking about I'm going to spend the last few minutes talking about killbots. Killbots, sometimes called lethal autonomous weapon systems or laws. A killbot is any machine that... I don't even have a definition here. These slides are out of date. Yeah, so killer robots are machines that can target, track, and initiate lethal force without human control. So a killer robot is a robot that has the capacity to initiate lethal force against another human, against a human being. These killer robots are sort of automated or autonomous weapon systems. They're not new by any means. Maybe a sort of simple version of an autonomous weapon system is landmine. Oh, actually, I know I have. Sorry, give me 1 second. I think I have a better slideshow here. This is the wrong one. Here we go. No. Here we are. Yay, I found it. Sorry about that. I'll put this in the slideshow also. This is autonomous weapons. All right. Yeah. Okay. So autonomous weapon systems. We often think about these the Reaper or the X-45. These drones, unmanned aerial vehicles. These are really not autonomous weapon systems. The Reaper and the X-45 are both remotely controlled autonomous weapon systems. So these systems have some pilot. These pilots are not in the plane; they're back on base somewhere. And in fact, they can be on the other side of the planet. Typically, these drone pilots are operating from within the United States. They're operating at some base in the United States, and so they can go home to their families after work. This is actually a source of a lot of psychological stress for drone pilot operators. Drone pilot operators tend to have the highest suicide rates in the military. They tend to be prone to depression and this kind of stuff. But it's because they're basically playing a video game where they actually kill people. So they have these sort of elaborate structures where they're controlling these unmanned vehicles. They have total control over the vehicles. They can set it to do certain automated routines, like do a patrol loop or whatever. But it's not going to initiate any kind of force without the drone pilot operator doing the action themselves. Right. So these unmanned aerial vehicles are not autonomous, but they are quite. They're used quite often. This is actually out of date now, but if you go to the link here at top, this is a website that maintains that maintains data on the drone war. Oops, come on. Drone warfare. Here we go. Yeah. So here's the website. So this website. Maintains records. So the U.S. policy on casualties in war is that we maintain records about our own casualties in war, but any other casualties, including civilian casualties and opponent casualties, are not tracked by the U.S. Are not officially tracked by the U.S. So you have to have other independent journalist outfits doing this kind of tracking, and you can see some of the results of fights over the last few years. One thing to notice here is that Barack Obama comes into office in 2008, and a lot of these drone strikes are Obama's drone strikes. Obama was the drone president. He sort of pulls us out of Iraq, and he limits our ground forces pretty substantially, but he compensates for that by dramatically expanding the drone strike program. And then Trump inherits that drone strike program, and Trump uses drones I think as frequently now as Obama did in his day. In contrast, George Bush didn't use drones a whole lot. In 2006, he did use some, but there were a lot of big mistakes that Bush made. In particular, there was one drone strike that we thought we were attacking a terrorist training camp, and in fact, it was an elementary school. Some huge number of like 80 kids died from one bombing strike at a school. 75 kids died. So that's sad. I mean, you can imagine how the United States would respond if some foreign country bombed one of our elementary schools. So this is the legacy of drone strikes in the United States. But this is all sort of traditional. In some sense, it's traditional warfare in that it's still human beings operating these things. And because it's human beings operating these things, the response, the sort of humanitarian response, are things like this. So these drones are operating a mile overhead. To the point that you can't even see them. You maybe hear them buzzing overhead when they get in close, and that means that there's a strike about to happen. But they're operating on a base, in the United States through their video game console, and that might make them sort of disassociate or not take seriously what they're doing, which is killing people. And if you listen to some of the comms from these drone pilot operators. When they get a direct hit, they call it a bug splat because that's what it looks like from the drone. It looks like a little dark splat on the ground. And in order to convince the drone pilot operators that in fact they're not attacking bugs, they're actually attacking people, killing people. People in Afghanistan, I believe this is in Afghanistan, they printed up this big portrait of one of the children who was killed in one of the drone strikes. and then put it on a field so that the drone pilot operator flying overhead remembers that there's a face with eyes. In fact, this is actually psychologically there's a very strong basis for thinking that this would work. It turns out that when we see eyes, even just a picture of eyes, we behave differently. So like you have at a buffet, like a food buffet, or like at a conference when there's like cheese and crackers or whatever, if you have on the cheese and crackers table, if you have pictures of people where their face is very clear and their eyes are very clear, people take less food from the buffet, from the cheese and cracker table. People are more sort of socially aware, conscious, when they feel that they're being looked at. So a big picture that looks like it's looking at you could be very effective in this kind of situation. Okay, but again, these are all manned weapon systems. When we're talking about autonomous weapon systems, or lethal autonomous weapon systems, we're talking about systems where the machine has control over lethal force. The way this is often discussed in the literature is meaningful human control. That there's a bunch of groups right now trying to outlaw or trying to get international treaties against autonomous weapon systems, and their policy, the catchphrase that they're fighting for, is that all weapons should have sort of meaningful human control, so that it's a human always pushing the kill switch, right? That the machine is never making a decision on its own, that it's always a person. And the argument here, so in the self-driving cars debate, there's this argument that we should have more self-driving cars because the cars will make, maybe not now, but eventually the cars will make better decisions than humans, and so less people will die on the roads. Cars kill tens of thousands of people, I think 35,000 people every year, just in the United States. 35,000 people is the size of a city, or like a small town, being killed every year as a result of vehicles. If we can reduce that number even a little, even by 10%, that would be 3,000 lives, 3,500 lives saved. So it seems like there's a strong push in the self-driving car market to replace human drivers for safety considerations. But the exact opposite rhetoric is used in the autonomous weapon systems debate. So they want human beings in control, and it's not because the human beings will make better decisions. The argument is not that humans have better control or will make better decisions. Human beings make mistakes all the time also. The thing about human beings, though, is that we have existing policies and procedures for addressing human mistakes, for correcting human mistakes, for holding the people who made those mistakes accountable. Right? So there's a whole framework of accountability in the military for when people do bad things or wrong things. Maybe that system isn't perfect. It definitely isn't perfect. But maybe there's a lot to criticize about that system. But at least that system exists. And the argument here is that if you give the machine the decision power over lethal force, and you take that decision out of the hands of human beings, then you also remove all of the control structure, all of the accountability structure, the infrastructure that we have for managing these kinds of decisions and managing when things go wrong. Like, if it's a person that makes a mistake, you can fire that person, or you can put that person in jail. But if it's the robot that makes a mistake, and no person had control over what that robot did, then what happens next? So no, I don't need. I can stay in this. Okay. So just as some examples of autonomous weapon systems, a very easy example. It's quite common are things like landmines. This is sort of an old example, but it's an autonomous weapon system in the sense that no person is pulling the trigger. The way landmine, it's a bomb that gets set off when someone steps on it. So the idea is that the kill switch here is sort of self-triggering, or is triggered when someone passes over it. And this is, you might think it's outside of human control. It's not a person sitting there pushing a button, knowing that it's detonating at the right time. Right? It's just the mine going off when someone passes by. And this is really dangerous. Landmines kill lots of people every year, partly because the losing side of a war typically doesn't go around digging up all the landmines. Right? If there's a war and there's a lot of landmines used, when the war is over, sometimes those landmines stay buried. Sometimes they stay buried for years, and people forget that there was a war there. And then some kid is walking through a field and accidentally steps on an old landmine that was never triggered, and then blows up. Right? So this happens a lot more often than it should. And so there are laws there's international treaties against the use of landmines. So you can use landmines in a war situation, or if there's like a military border that's sort of an active threat, it is within the norms of international policy that you can use landmines, but in order to use landmines, what makes it legal is that you keep track of where you put those landmines. You have to have reliable records of everywhere you put those landmines, so that when the war is over, those landmines can be dug back up and deactivated. So if you're using landmines without tracking where you're putting them, then you're in violation of the international war treaties. Okay, so that's a sort of an old example. It's been around for generations of a sort of autonomous weapons technology about which we have actual laws. Here's maybe something. I'll turn off that music. Here's maybe something that looks a little more familiar as a autonomous weapon system. This is a turret, an automated turret. The automated turret can track and target, so it has little cameras and it can move around. So this is like a real automated turret. It's been around for a few years. This is actually built by Samsung. The same Samsung that might have built your phone. Samsung is a South Korean company. South Korea, at least for a long time, was in an active war with North Korea, and so there was a thriving military industry in South Korea, and Samsung is part of that military industry, and it builds military technologies for South Korean government and other governments, including these automated turrets. So if people are moving in front of the screen, it draws little boxes around them, very similar to those little boxes drawn by the Tesla vehicle as the Tesla vehicle drives around. But so it can see where people are moving, it can track them and follow them, and in the original versions of this hardware, there was an automated fire routine where you can put it in sort of auto fire mode so that any movement would get initiated on, or any movement detected as a person would get initiated on. Like I said, these came out a while ago, and when they were put into service and it was discovered that these had an auto fire routine, there was a big international outcry that these were unsafe, they were dangerous, that automated technologies like this shouldn't be used. The argument was not that you shouldn't have turrets, but that if the turret's going to fire, it should be a person making the decision to fire. Right? It should be a person monitoring those cameras and then deciding deliberately that this is a situation that requires lethal force. Because again, a kid could run out in front of the turrets or whatever. There shouldn't be kids in the demilitarized zone. But if there is, you want a person to be making these decisions. The argument goes. Maybe a more advanced a version of this. This is the LRASM, the Long Range Anti-Ship Missile. This is sort of a fully autonomous. So it's an anti-ship missile. It's essentially a bomb, but it's a bomb that can control itself, sort of like a long-range Tomahawk missile or something that can do active guidance and steering. And again, these things have also been around for a while. The idea here is that if you're, especially in the Navy, and you're operating on global scales, it might be that your opponents are so far away that they're beyond the horizon of they're beyond the horizon of the Earth, and so you can't actually see them visually. And that, so if you can't see them visually, you also can't see them with radar and other things, and that means you don't know where to send your bombs. But it might be that because these bombs move so fast, and because wartime activities are so fast-paced, it might be that you need to fire off your missile now to make sure it gets there by the time you can actually see over the horizon. Again, the challenge here is you don't know exactly where you're firing, so the idea is that you send out these long-range missiles which can target themselves, so you just shoot it up into the air, and then once it gets high enough, it has line of sight where it can see what the targets are. But not only does it see what the targets are, but it can also detect which is the most important target. It can sort of classify the kinds of ships that it's looking at and figure out which one is the most important. It can do evasive maneuvers in order to avoid detection by those ships, avoid detection by other kinds of vehicles. You can put this on your carriers. You can put this on your planes. That's what those. If you want to know what those missiles are underneath the wings, they're usually these long-range missiles that can go and fire themselves. Right. So there's a little animation here of this is where the targets inside this whole window here is being actively monitored, and so the long-range missile knows to sort of skirt along the outside of these detection points, and it can adjust this operation in real time as the situation on the battlefield changes. Again, the idea here is to give the military control, a long range, the capacity to initiate force at a long range, and to do it in a way that is that is viable. So these kinds of things exist. They're self-firing autonomous weapon systems. So there's no right now, there's no international treaty about regulating these autonomous weapon systems, but there have been a lot of work trying to understand and classify these weapon systems. This is a paper by Roth from 2016, where she looks at all the known declassified weapon systems from countries, from all sorts of different countries, and then classifies them by sort of the level of autonomy in terms of mobility and the level of autonomy in terms of their weapon systems. And so we can see that they sort of fall into some groups. And maybe some of these groups are okay or within the norms of normal combat, but maybe some of these are particularly worrisome. We just looked at the LRASM. There's also the Neuron, which is, I think, a French autonomous weapons system. As military forces, as state actors start to develop these autonomous weapon systems, there's also been a lot of pushback. In particular, there's been the Campaign to Stop Killer Robots, and the ICRAC is the International Committee for Robot Arms Control. So these are two international groups sort of dedicated to developing international bans on lethal autonomous weapon systems. Campaign to Stop Killer Robots is almost constantly lobbying the UN. There's a regular meeting at the UN in Geneva called the CCW, the Convention on Conventional Weapons. Conventional weapons. This is the international, the UN body. The CCW is the UN body that decides on bans on certain weapons systems or bans on certain kinds of military activity. It's through the CCW that we've had successful international treaties against chemical weapons, biological weapons, nuclear weapons. There's been this might have changed dramatically in Trump time. I think, in fact, it has changed in Trump's time. But it used to be the case that we had seriously denuclearized after the Cold War. We had decommissioned a lot of the old nuclear weapons. We stopped building new nuclear weapons. I think we just started building new nuclear weapons again, which is just very stupid. But this deregulation or denuclearization is a result of these treaties that tend to go through the CCW. There are also treaties against biological weapons and chemical weapons. Not to say that these weapons aren't used. Sometimes biological weapons, sometimes chemical weapons are used. Chemical weapons, more often than you think. Chemical weapons are banned by international treaty. You're not allowed to use chemical weapons in a military conflict with a foreign power. However, that doesn't stop the use of chemical weapons for domestic issues. So pepper spray is a chemical weapon. Tear gas is a chemical weapon. Chemical weapons are legal to be used. I mean, there's no international treaties. I mean, countries can, to some extent, police themselves. And so when the police force sprays tear gas at a protest or whatever, that's a kind of chemical weapon attack. And that would be illegal if those protesters were foreigners and this was an international conflict. But because they're citizens of the country that's spraying the chemical weapons on them, it's not illegal by international law. So chemical weapons do get used. Biological weapons also do get used. But they're against international norms. If someone was found using chemical weapons or biological weapons, this is usually the sign of a sort of a serious violation of international norms, and it usually results in things like sanctions, other kinds of policy responses from other state actors. So the idea is that these regulations on chemical, nuclear, and biological weapons have been effective. They've not entirely stopped these weapons, but they have controlled them quite a bit. We're a lot safer from the harm of these weapons because of these international treaties. And so the Campaign to Stop Killer Robots and ICRAC, ICRAC, I think they say, they both want to do the same thing for autonomous weapon systems. They want to have international bans that are like the chemical and biological weapons bans, but for the development and use of autonomous weapon systems. This stuff also gets kicked off back in 2015 when Elon Musk donated, I think, $10 million or $20 million to the Future of Life Institute. So the Future of Life Institute it's a think tank. It's like a research institution, sort of independent research institution where they think about existential risk. Existential risk are things that threaten all of humanity, things like nuclear weapons, biological weapons, but also things like climate change, which is not, there's no hostile actor there. And in 2015, Elon Musk has been going around talking about existential risk from artificial intelligence for a long time. I'll say more about this in class on Thursday, I think. But Elon Musk has been sort of fear-mongering about existential risk for several years, and in 2015 he put his money where his mouth is, and he gave the Future of Life Institute, I think $20 million, $10 million, to start to study artificial intelligence and what risks are posed by artificial intelligence. And as partly to commemorate this big research investment, a lot of different groups, including the Campaign Stop Killer Robots, got a piece of that big chunk of money in order to study some of the impact of AI. And as partly to kick off this big research investment, the Future of Life Institute got a couple of very prominent AI and robotics researchers to sign on to this open letter, which I'll read in a second, but let's look at the signatures really quickly. Stuart Russell, Niels Nielsen, Barbara Groves, Eric Horowitz. These are all very prominent, well-known computer scientists, roboticists, people. Demis Havilis is the CEO for DeepMind. Jan LeCun is the head of Facebook AI research. Jeff Hinton, Peter Norvig. We've talked about some of these people, Francesca Rossi. So these people are all very prominent industry people or researchers in computer science and technology. These are like serious players. Also a bunch of non-computer scientists like Elon Musk and Stephen Hawking, when he's still alive, Steve Wozniak, Max Tegmark, Noam Chomsky, also signed on to this. A letter, actually, let me, if we go to the full list of signatories, yeah, you can see also that prominent AI researcher Daniel Strada from NJIT also signed this letter. Okay, so what does the letter say? I'll close with this. So I'm not going to read the whole thing, but I just want to read a little bit of it. So the letter argues that artificial intelligence technology has reached a point where the deployment of such systems, practically, if not legally, is feasible within a few years, if not decades, and the stakes are high. They say autonomous weapon systems have been described as the third revolution in warfare after gunpowder and nuclear arms. Right? So the idea here is that there's a new revolution in the sort of state-of-the-art technology, and their worry here, to be absolutely clear, that worry here is not that robots start killing humans or robots try to take over the world or anything like that. The risk here is not that robots attack people. The risk here is instead that developing autonomous weapon systems will lead to a global arms race. A global arms race like the nuclear arms race that pretty quickly put us at existential threat of planetary human destruction. So maybe we don't have complete existential risk by autonomous weapon systems, but maybe it's just really bad for humanity to have global arms race in autonomous weapon systems. In comparison to the Kalashnikovs of tomorrow, the AK-47. AK-47 is like it's a really cheap weapon, and it's ubiquitous. It's sort of the terrorist tool of the trade. You see them everywhere, especially in places of conflict, or terrorist conflict, or rebel resistance. Kalashnikovs, because they're cheap, because they're pretty reliable, you see them everywhere, and it's made the world a worse place. And so this article is trying to get autonomous weapon systems banned before they get developed seriously. And again, the comparison to chemical and biological weapons, just as most chemists and biologists have no interest in building chemical and biological weapons, most AI researchers have no interest in building AI weapons and do not want to tarnish their field by doing so, potentially creating a major backlash against AI. So, actually, the idea is that not just for the sake of humanity, but also for the sake of AI, that if there's a bunch of killer robots wandering around killing people in very unjust ways, maybe this creates a public backlash against AI and prevents the possible benefits of AI from coming to fruition because people are just afraid of killer robots. All of these researchers suggest that we don't develop autonomous weapon systems. There's the opposing view also. There's people who argue that autonomous weapon systems will make us safer, or that it's very common for people to argue that autonomous weapon systems are inevitable, and so you just have to, we should get them first because other people are eventually going to make them anyway. I mean, one of the problems with autonomous weapon systems is that they're based on technology that isn't particularly expensive. Nuclear weapons, they're old technology, and it's sort of well-known technology. It's very easy to get your hands on the designs for nuclear weapons, to understand in a great technological detail how a nuclear weapon works. The problem is that it's just really expensive and difficult to build. You need high-end engineering equipment. In particular, you need a bunch of centrifuges in order to separate out the purified uranium that's going to initiate the nuclear explosion. To separate that out from all the rest of the uranium that's not really useful for nuclear weapons. Those centrifuges, they tend to be really big and expensive and difficult to operate. Because they're really big, they're the kind of things you can see from space. So it's really easy to just use satellites to monitor how people's nuclear weapons technologies are developing by just looking at how many centrifuges are they running. Because nuclear weapons are so difficult to develop, or sort of comparatively difficult to develop, it's sort of easy to keep track on them. This isn't so much the case for chemical biological weapons, so it suggests that this isn't the biggest constraint, or that you can constrain weapons that are. I mean, again, chemical weapons have been used. In World War I, we used a lot of chemical weapons, mustard gas and so on. Just the fact that the weapons are available, that they're cheap, that they're easy, that they're very destructive, doesn't mean that people will use them. People don't use mustard gas anymore because it's awful, and we learned how terrible, how just inhumane the use of mustard gas was in World War I and II. And so people sort of the world over have agreed we're not going to use mustard gas anymore. And we can do the same thing for mustard gas isn't particularly difficult to manufacture, but we just don't do it because it's so bad. And we can do the same thing for AI. At least that's the hope. To try to get this thing to go through, the Future of Life Institute, this $10 million, part of that $10 million, I think maybe a wasted part of that $10 million, went to the production of this video called Slaughterbots. I don't like this video so much. But this is a fictional narrative designed to dramatize the threat of autonomous weapon systems. And this was produced by the Future of Life Institute, so you can think of this is produced more or less indirectly by Elon Musk. I'm not going to show the whole thing. I'm just going to sort of scrub through it. But it starts off with this sort of TED Talk-like scenario with a CEO-looking dude talking about these little tiny miniature drones. So these drones don't actually exist. Again, this is just a dramatization. This is imagine what would happen if. But the talk here is supposed to show that these little drones can be actually really dangerous. So they give this example of the drone coming in here and sort of popping this dude on the head, this little mannequin on the head, and killing it. And so the idea is that the little drone, it might seem really not lethal, but when used in the right way, it can be a lethal machine. Okay, so TED Talk guy gives this sort of nightmare scenario of the use of these killer robots, and then shows some sort of police situations where these robots might be used, sort of to help law enforcement. Sort of the advantage of these machines get into small places that you can make a bunch of them. There's these sort of very scary graphics of there's like thousands and thousands of these little drones, each one that can kill a person, being dumped over some country. Right, so this is the fear. Now, I'll remind you that we don't have technology like this, and in fact, it's probably pretty stupid to use technology like this in a vast bombing campaign. It was easier to drop bombs. Bombs are cheaper. They're more likely to kill people. They cause also infrastructural damage. I mean, you use these little bots, you might kill the people, but you're not going to damage any of the stuff, of the equipment. It's also probably pretty easy to knock these things out of the sky. So this hypothetical scenario that they're sort of going through doesn't seem very realistic, but they go from that into a bunch of fake news headlines, literally fake news headlines. These aren't real news broadcasts. These are sort of fake clips of not real generals or whatever, pretending that there's a huge killer robot epidemic happening, and then what do we do about it? So then the story switches from this person, from all these news headlines to this woman on the phone with these things. So this woman is being afraid of all these killer robots, and then is talking to her son. So here's her son, who's a college-age student, just doing his college thing with his other college roommates. Very normal college student. And then what you get is a discussion of a shot of him at school, some more scary headlines, some terrorists here released out of the back of their van. A bunch of these little self-controlled drones. And then the idea is that these drones go to the campus where that boy's in school, and then they have this little clip of these machines breaking into the school and then flying into a classroom and then killing everyone in the classroom. And you have this sort of dramatic call from the son to his mom while the mom's watching in fear, and the son's like afraid of these robots killing everyone in the school. So again, these robots aren't real. There's no situation like this happening. There's also not even really the threat of these kinds of things happening. Right? When we're talking about autonomous weapon systems, we're not talking about a bunch of little cheap drones being flown out like this. I mean, again, because it's really just not effective. I mean, these things are probably pretty expensive. To get this many of these drones is probably a hugely expensive task. And if all you're doing is shooting up a school, I mean, we see on the news headlines all the time about people doing this with just a single assault rifle or whatever. So there's cheaper, more effective ways to do this kind of terrorism if you want to do it. I don't know why the high-tech terrorism is any more scary than the actual terrorism that we see from existing technologies like guns. But what's going on here is that, again, this is a dramatization to try to overhype the fear of these killer drones. There's no suggestion that the main target of these attacks, I mean, these drones are going to be used mostly by really well-funded militaries like the U.S. military against not so well-funded countries overseas. There's not, as far as I know, there's not real suggestion that there's a threat of school shootings using autonomous weapon systems. At least that threat isn't any bigger than the existing threat of school shootings. And really, that's what's going on in this video, is that they're trying to, like the images that you see in this video are not images of any realistic killer robot scenario. These are images of school shootings. And these are images of school shootings that we, as Americans, as people in the West, have become increasingly familiar with. Right? There's a real epidemic to fear about school shootings, about people going into schools and terrorizing the people and killing a bunch of people. This is something it's a real existing fear that people have, driven by actual events. And this video is trying to co-opt the existing fear of school shootings and sort of transfer that same fear onto a fear of killer robots. Now, I signed the letter. I'm all in favor of the ban of killer robots and so on. But this seems to me like just hype. It seems to me like hype that distracts from the real issues. And it's just trying to oversell the risks for the sake of a compelling, like a maybe controversial video. So, like I said, Future of Life Institute produced this when ICRAC and Campaign to Stop Killer Robots, when they go to the UN to talk about stopping killer robots, they sometimes screen this video. Right? So this is part of the argument to make, is that this is the kind of things that we want to avoid. I think this is a disingenuous argument. I think this is a sort of hype machine, that if they really wanted to talk about stopping killer robots, they should have been talking about militarized conflict. But talking about militarized conflict like that is a lot more politically risky. It's a lot more ethically ambiguous. And so if you associate it with a school shooting, which has a more sort of clear-cut ethical narrative that's sort of already well embedded in the culture, so they're sort of using this to scaremonger for killer robots. I think that's sort of tasteless. Not only is it not very convincing, but it's also kind of tasteless. But that's the situation that we're in. Okay, I've been talking for too long already. I'm going to go ahead and stop lecturing, and thank you for listening. I will see you all on Thursday. I hope you enjoy. Enjoy your weekend. Okay, bye.